Hello everyone and welcome back. Today we have 2706 buy 2 chocolates. It says here that you're given an integer array prices representing the prices of various chocolates in some store. You're also given a single integer money which represents your initial amount of money. You must buy exactly 2 chocolates in such a way that you still have some non-negative leftover money. You would like to minimize the sum of the prices of the 2 chocolates you buy, and then return the amount of money you will have left over after buying the 2 chocolates. If there is no way for you to buy 2 chocolates without ending up in debt, then just return the initial money. Note that the leftover must be non-negative. Okay, so we have these 2 examples here, and I did import them over here, and let's go through them. So we have some chocolates, right? Some list of chocolates, and we have some starting money. We have some list of chocolates and their prices and some starting money. It basically means we're trying to reduce the amount of money we spend to buy exactly 2 chocolates. Let's say the taste and the quality is all the same. Our main goal is to reduce the amount we must spend to buy exactly 2 chocolates. And if we cannot, then we don't buy anything and we just return the starting money. And if you can believe it, it actually is as simple as it sounds. We basically can, there's 2 ways. One is the easy way. It's a few extra iterations where we first sort it, right? You first sort the chocolates by price in ascending order, and then you just add the first 2, sort, and then the first 2 will be naturally the lowest cost chocolates, and then return those. So in the first example here, we have 1 to 2, which is already sorted. 1 plus 2 is 3, right? Then, yes, we have enough money to buy these 2 chocolates. We spend 3, and we can return 0 after paying for the 2 chocolates. In the second example, when we sorted, it's 2, 3, 3. Now, in this case, to buy 2 chocolates, we need at least $5, which we don't have. We don't have 5. We only have 3, so we return 3 and indicate that we could not buy any chocolates. All right, so let's try the first way first, which is all we did was prices dot sort, just have it sort ascending, and we're saying that the cost is prices, and we are guaranteed to have a minimum of 2 values, so we can do this, which is prices of 0 plus prices of 1. These would be the minimum 2 cost prices, and then if as long as this cost is less than or equal to our initial starting money, we can return money minus whatever the cost is. Otherwise, if the cost exceeds our start money, then we just return money. And let's do that first. Okay, so that does work. Now, there is another way, which is, so this one, if we think about it, the time is O of n log n because we sort, and then space is constant. We're just using constant variables. However, can we do better? We can. It's a little more complicated, but actually quite simple as well, which is what if instead we keep track of 2 values. So we know we just want the 2 lowest amounts. Then let's say that we have like 2, 3, 1, and 5. This is the cost of all the chocolates. Okay, and we say, all right, there's some value 1, which will be the smallest amount, and then 2, which will be the next smallest amount. And we can initialize this as some max number, okay? And then what we do is we iterate our prices and say, all right, I'm at 2. Is 2 less than our smallest number? It is. Okay, so let's update it to 2. Okay, and 2 will take whatever 1 was previously, which is still max. It's the same. That's okay. All right, now we are here. Okay, and then we say, hey, is 3 less than our smallest value? It's not. All right, but how about 2? Is it smaller than 2? Yes, it is. So let's update this to 3. Okay, and then we can move this here. And when we're at 1, we once again start with the smallest value and say, is this number, which is 1, is this smaller than 2? Yes, it is. So we say, okay, 1 is smaller than 2, but then this number is smaller than 1. So let's have 2 take whatever 1 is, which is 2, and then 1 take whatever the current number is, which is 1. All right, and we're on our last cost, which is 5, and we say once again, does the current price, is this less than our current smallest price at 1, which is 1? It is not, so we're done. And then we have these 2, right? And the rest is the same. We add the 2 costs, and let's say we never initialized the start money, but let's say it was 3. Then we can say, hey, 1 plus 2 is 3. Yes, we have enough money to spend to buy these 2 chocolates. If this happened to be 2, we would just return the initial start money because we don't have enough money. All right, now let's translate that to code. What did we do? We had some initial value here, 2, and this is the smallest, and next smallest. All right, and then we did for price in prices. First, we check is the current price, is this less than our smallest price? Less than 1. If price is less than 1, then 1 and 2 will be updated to, let's make it clearer. Okay, 1 and 2 will be updated to 2 will take whatever 1 was before, and 1 will take whatever the current price is, which happens to be less than itself. Okay, so 1 is now the price, and 2 takes over the previous value at 1. All right, and then is that all we did? We update wherever it's less. Oh, okay, there's a second thing. Otherwise, if price is less than 2, then we can update 2 to the current price because this price may not be less than 1, but it is less than 2. So we update it accordingly. Now at the end of this loop, 1 and 2 will hold the 2 smallest prices in prices. And once again, we are guaranteed to have at least 2 prices in the array. So we can say cost is equal to 1 plus 2. And as long as the cost is less than or equal to our starting money, then we return the money minus whatever the cost is. Otherwise, return the start money. You can submit. All right, and there you have it. This was once again 2706 buy 2 chocolates. And in this version, our time is O(n). We iterate at most once through every chocolate, and space is still constant. Thanks so much. Happy coding. See you next time.